So we've got a few more shapes you can look at. We noticed that for a sphere, the set of all points in 3 dimensions equidistant from a center, equidistant from a single point, we know the surface area is 4 pi r squared. So a sphere of radius 3 has surface area equal to 4 pi times 3 squared, and so we end up getting 36 pi square units. We know that the volume of a sphere is given by V equals 4/3 pi r cubed. So the volume of that 3-unit radius sphere, so the same 3-unit radius sphere, has V equal to 4/3 pi times 3 cubed, so we end up getting 36 pi units cubed. So you notice that's kind of unique to 3. We notice that if we had said r equals 7, let's say 7 meters, you know surface area is going to be 4 times pi times 7 meters squared. We get 4 pi times 49 square meters. And that's going to give us 196 pi square meters. And its volume is going to be 4/3 pi times 7 meters cubed. Gives us 4/3 pi times 343 cubic meters, and so we're going to wind up getting 686 times 2 is 1366 divided by 3 pi meters cubed. Let's double check that. 2 times 343 is 686. Multiply that by 2, we get 12, carry the 1, 17, carry the 1, oh no, 13. So 1376. Always have to watch the arithmetic. And of course you're allowed to use calculators. A cylinder is a right cylinder is a pair of circles parallel to each other joined by a curved side. So classic can shape. And we notice now our surface area, if it has a radius, if the base has a radius r and a height of h, we know surface area is going to be pi times r squared times 2, because we have a top and a bottom, plus 2 pi r h. We can imagine the sides of that cylinder being stretched out. We can essentially unroll it, and there'll be a rectangle height h and a width of 2 pi r. And so now the area of that, we call that the lateral surface. Lateral area equals 2 pi r times h. And so a cylinder with radius of 4 centimeters and height of 6 centimeters has surface area equal to 2 pi times 4 squared. So we have 2 pi times that 4 centimeters squared, plus 2 pi times 4 centimeters times 6 centimeters. And so we end up getting, it's going to be 32 pi square centimeters, plus that'll be 48 pi square centimeters, and so we get 80 pi square centimeters. And then you notice that if you multiply 80 by pi, you get something a little over 240 pi square, or you end up getting a little over 240 square centimeters. Volume of a cylinder is just the area of the base times the height. And so we're going to just get pi r squared times h. And so for that cylinder we were just talking about, we notice that if r is 4 centimeters, h is 6 centimeters, then the volume is pi times 4 centimeters squared times 6 centimeters. So we're going to get 16 times 6 is 96. We get 96 pi cubic centimeters. And we actually notice it's interesting. We can actually have the volume and the surface area aren't necessarily connected. We can have a gigantic surface area with a very small volume if we just make it very flat. And so bigger volume doesn't always mean bigger surface area doesn't always mean bigger volume. It can, but it doesn't have to. For a cone, where we basically have a circle with a sides going up to a point, if we have a height of h, actually we have to be careful now, much like we saw with the pyramid, a cone can have a height and a slant height, so you've got the actual height from the base up to the point, the vertex, and then you also have that slant height. So be careful. Be careful that we have a radius, height, slant height, and slant height are not the same. And what we're going to notice is that we can look at a cross section. If we have h and r, we know L by the Pythagorean theorem is going to be the square root of h squared plus r squared. So if we know what h and r are, we know what L has to be. So for instance, if we were going to say, first we need to know some formulas. We know that the surface area for a cone is equal to pi times the radius times the slant height. And this takes, we're not going to go into this in a lot of detail, this takes some tricky arithmetic, tricky geometry to show why that works. But surface area for a cone we know is going to be the pi RL plus the area of the base. So we call this the lateral surface area. For the sides, and then the base is, unsurprisingly, the area of the base. And volume is actually kind of like what we see for the cone, or sorry, for the pyramid. Notice the volume for a cone is going to be 1/3 pi r squared times h. So essentially 1/3 times area of the base times the height. So if we had a cone, if we had a cone with a height of 12 and a radius of 5, let's make that bigger so we can see it. So if we know the height is 12, so let's make it 12 inches, and the radius is 5, we notice the volume is easy enough. We know the volume is going to be 1/3 pi times 5 inches squared times the 12-inch height, and so we end up getting, that's going to end up being 4, 1/3 of 12 is 4, so we get 4 times 25 is 100 pi cubic inches, and so that's because we get 100, we notice that's going to be approximately 314 cubic inches. The surface area is trickier because we notice we need to find out the slant height. We know that 5 squared plus 12 squared is 25 plus 144. 144 equals 169. And so we know that the slant height has to be the square root of 169 is 13 inches. And so we know that the surface area is going to be pi times the radius of 5 inches times the slant height of 13 inches, and so we end up getting 65 pi square inches. And so that's going to be around 200 square inches. So we're not going to get too concerned with composite figures. We'll just notice that if we had, for instance, given a box, let's say a cube, with a sphere removed. Let's put it this way. Give me a cube with side length 8 meters with a sphere of radius 4 meters removed from it. That is the volume. We notice that we're really just thinking of the volume of the cube minus the volume of the sphere. And so we're going to wind up getting 8 meters cubed minus 4/3 times pi times 4 meters cubed. So 4/3 pi times the radius cubed. Make sure that's a 4, not a 9. And so we end up getting 64, 122, 512 cubic meters minus, that'll end up being 256/3 pi cubic meters. And so you notice you're not going to have to worry about that terribly precisely. We know that if we take pi divided by 3, that'll be around 1. So roughly, this will be approximately 256 cubic meters. This is very approximate.